All right, maximum minimum problems. Again, I'm not going to go through every single problem in our notes booklet, but I will go through a few, and I'll show you algebraically how to solve them in two different methods. Okay, one is by completing the square, and then the other one is just by finding your vertex value and going from there. So we're first going to read the problem. A rectangular enclosure for a dog is made using one wall of a barn. Find the dimensions of the largest possible enclosure if 400 meters of fencing will be used for the three sides. So here's our barn side, and we want to create a area for dogs where we're fencing off these three sides, and we're using 400 meters of fencing. So obviously, if this is a rectangular enclosure, these two sides are going to be the same. So let's call this W and W, and this is going to be our length. Okay, we're going to obviously need two widths to create our fencing and one length, and that's going to equal 400 meters of fencing. We're also trying to maximize or find the largest possible enclosure, so that relates to the area. Okay, and the area of this pen would be length times width. Okay, so we obviously can't maximize something with three different unknown values. So what we want to do is we want to work with this information that we know about fencing and either talk about length in terms of the width or width in terms of the length. It doesn't matter, but you want to pick one that's a little bit easier. So what I'm going to do is I'm going to rearrange this equation by solving for the length, and then I'm going to write that expression and replace it for length in this area formula. So so length is really going to be negative 2W because I'm bringing 2W to this side plus 400. So I'm now going to replace my length in my area formula with negative 2W plus 400. Okay, and then we need to multiply that by the width. So I'm going to run this through my set of brackets, and my area is going to be negative 2W squared plus 400W. All right, so at this point, in order to maximize my area, well, maximum relates to the vertex of any quadratic or parabola. So if I'm trying to find the largest area, and this is the parabola formula or the quadratic formula that I'm giving, then the maximum point to this quadratic is going to give me my largest area, because the two things that I'm comparing in this function is W for the W of the pen, and A would be the area of the pen. So the Y value of this vertex is going to give me the maximum area. All right, so two ways to do that. One way is by completing the square. So I'm going to take you through again on how to complete the square, which we've done quite a bit about already. So we're going to factor out this negative 2. 400 divided by negative 2 is a negative 200. We're going to leave a space there. We're now going to balance this out, so I'm going to take 200, divide it by 2, and square it. So 100 squared gives me 10,000. We're now going to balance this equation out. By taking 10,000, multiplying it by negative 2, so I haven't really added 10,000, I've actually added a negative 20,000. So to balance that out, I should be adding 20,000 here. Okay, from here we're going to simply factor this, and now this is in vertex form. So what does this tell me? Well, my vertex would be 100, 20,000. So this tells me, remember what we talked about initially? This represents the width of my pen. This represents the maximum area that my pen can hold, which is what we want. We want to find an enclosure that creates the maximum area. So the width of my pen is going to be 100. The length of my pen would be 2 times 100 plus 400. So the length would be 2 times 100 plus 400. So the length would have to be 200. So the dimensions are 100 by 200.